Okay guys, so what we're going to be looking at here is we're finally going to start here in second trimester by learning something a little bit different. We just finished up with derivatives. You probably hated related rates. You probably hated optimization. But overall, hopefully you understand what a derivative is used for. What we're going to be talking about today is an introduction to a slightly different idea that's going to take us in a different direction. And what we're going to be talking about here are what are known as antiderivatives. Now, if I were to ask you, it's kind of like a multiple choice question, what did we take the derivative of to get 3x squared plus 2? If you were to look at these for a second, you'd say, you know what? I took the derivative of x to the third plus 2x to get the derivative of 3x plus 2. And I also, of these choices, I also took the derivative of x to the third plus 2x minus 7. So in this problem, you'll notice that there is more than one correct answer. And the reason for that is simply this constant on the end. When we take the derivative of a constant number, as you're well aware, we get 0. So if I was asking you what I took the derivative of to get something, there are a whole bunch of different answers that I could actually have that would tell me what I took the derivative of to get the function in question. Okay? So again, we talked about that already. The only difference was the constant. So if this were not a multiple choice question, if I was not asking you what did I take the derivative of to get this particular answer, the problem would be there are an infinite amount of different constant terms. So I could have had x to the third plus 2x minus 1, x to the third plus 2x minus pi, on and on and on, and every answer that you say would be correct. And so an antiderivative is what we took the derivative of to arrive at the function that we're kind of looking at. So we're asking ourselves, what did I take the derivative of to get this? Okay. So when I have, and we're going to deal with that idea that we were talking about before a little bit more in just a second. But before we do that, we have to look at this and we have to say, okay, what is exactly, how do I find the antiderivative? Now, the thing that is very difficult about antiderivatives versus derivatives is there's only really one rule that works every time. And then everything besides that is pretty much a case-by-case basis. The one thing that we'll still know how to take the antiderivative of is when we have x raised to a number power. If I want to take the derivative, or the antiderivative of x raised to a power, so if I had like x squared or something like that, if I wanted to take the antiderivative of that, find what I took the derivative of to get x squared, what we do is instead of subtracting 1 from the power, we add 1 to the power. And then instead of bringing the number down, what we do is we divide by what this new power is. And again, that only works for terms in a polynomial function. Everything besides that, and it's why integrals are, why antiderivatives are so much more difficult than derivatives in general. Derivatives, we know how to take the derivative of just about anything. The rules work no matter what. Antiderivatives are as important, if not more important, than derivatives, but they're much, much more complicated to deal with. So if I wanted to find the antiderivative of x to the 7th, it would be x to the 8th, because I add 1 to 7, and then I divide by the new power. If there's a number out in front of the x squared, we just ignore that number and apply that rule. So again, I add 1 to 2, 2 plus 1 is 3, divide by 3, and then generally you try and simplify, see if something will cancel like the 3's do here. So those 3's cancel and I've got x to the third. In this case, that 4 will stay there, so I would have x to the 8th divided by 8, and then the 4 and the 8 kind of cancel down, so I would have x to the 8th divided by 2, or 1/2 x to the 8th if you wanted to look at it that way as well. Okay, so all of those are an antiderivative of the function that we have. Okay, and if we have multiple terms like this one, I just use the same rule that I just talked about, but I just do it a term at a time. So the antiderivative of x to the 4th would be x to the 5th over 5. The antiderivative of 2x squared would be 2x to the 3rd divided by 3. Again, just adding 1 to the exponent every single time and then dividing by the new power. And then I would have 3x squared divided by 2. And that would be an antiderivative. That is one thing that I could take the derivative of to get x to the 4th plus 2x squared minus 3x. Now, that constant that we talked about, because technically I could put a plus 4 on the end of this, and that would still be an antiderivative, or plus 7, or plus 15, or plus whatever constant number I want to put on the end. I could do that, and I would be just fine saying that that is a correct answer. But if I were to ask you what is the general antiderivative, what is the overall antiderivative of this function, I don't want to have to write all of them down. And so what we do is we take this plus c and we just put it at the end of our antiderivative. And what that indicates is I know that there can be a constant number being added onto the end. I don't know what it is. Maybe it's there, maybe it's not. I don't know. But I know that there's a plus c that goes there, and I'm just going to make sure that it gets there so that I know when I find the antiderivative, there could be a constant number on the end. So if I wanted the general antiderivative of x squared plus 2x, I would take my antiderivative like we've been talking about, x to the third divided by 3 plus 2x squared divided by 2, and then the 2's cancel, so it's really just x squared. And then I would just put a plus c on the end of it, and that would tell me what the general antiderivative is. Just overall, this is what I would take the derivative of, x to the third over 3 plus x squared, plus some constant number would be my antiderivative. X to the fourth plus 5. That would be x to the fifth over 5 plus, now you have to think about it for a second. What did you take the derivative of to get 5? That was 5x, if you remember right. This is kind of like saying this is 5x to the 0, so I add 1 to it. And that gives me the answer as well. Then I get plus c. So I've got x to the fifth over 5 plus 5x plus c. That's my general antiderivative. Okay? Now, any function that is not a polynomial, you can think them through. Sometimes you can get them, sometimes you can't. There's a couple that you should know. The antiderivative of e to the x is e to the x plus c. The antiderivative of 1 over x. What did we take the derivative of to get 1 over x? Hopefully you remember it was the ln of x plus c. What did I take the derivative of to get the sine of x? Well, this one's a little bit tricky because this is the antiderivative, which means what did I take the derivative of to get sine of x? That would be negative cosine of x plus c. And cosine of x, I took the derivative of sine of x plus c to find that derivative. To find out when I took the derivative of that, I got cosine. Here's some that we should probably know that show up every once in a while. The antiderivative of secant x tangent x is just secant x plus c. Cosecant x cotangent x is negative cosecant x plus c. Secant squared, tangent x plus c. And cosecant x squared is negative cotangent of x plus c. So all of those are the only antiderivatives we will know for this entire class. There's not more that you can memorize. That's it. We've got 10 of them basically. We've got one rule that works for polynomials, and then, 9 of them. We've got one rule for polynomials, and then these 8 that we talked about right here, and that is all we have to work with. And what I mean by that is if you see anything else show up, you don't know how to take the antiderivative of that. Now, obviously, people are pretty smart, and they figured out ways around that. We will talk about some of those as we get a little bit further into the class. But know that that is what is going on with these antiderivatives. We have to find functions that we recognize how to find the antiderivative of. Okay? If things are multiplying together, if they are dividing, if there's anything like that, we simply cannot take the antiderivative of those, find the antiderivative just by looking at it. Again, we will learn some tricks as we get further into this course, but they were not things that we know how to do just right off the top of our head, and every situation is unique, okay? So if I wanted to know the antiderivative of cosine of x plus e to the x, I would just say the antiderivative of cosine is sine, antiderivative of e to the x is e to the x plus c. I'm all done, okay? Now, the last thing you might think about a little bit is what happens if you have like sine of 2x. This part in here is not super complicated, but it is something, and this is what I want us to think about. I'm not going to tell you how to do these just yet. I am going to tell you that the answer to this one is cosine of 2x divided by 2, or the antiderivative of e to the 2x is e to the 2x divided by 2, and both of those have a plus c on the end as well. So that is what those antiderivatives will be, and this will lead us into a conversation that we will have a little bit later in the course, so just be prepared for that. Again, this should be a fairly easy idea that shouldn't take too much time to think about, but if you have any questions, please let me know.